Meshing flip fluids in Houdini is a very simple process, and there is one node to rule them all, and that node is called particle fluid surface. And before I connect this node to my unpacked node, which is our flip sim here, I want to talk about a couple of things. First, the particle separation. And as you may have guessed already, this is the resolution of my mesh. So when I'm testing stuff, when I'm literally going to plug my particle fluid surface node to my flip sim for the very first time, I would want this number to be a bit higher than 0.1, because for a scene like this, for a big scene like this, even the default value of 0.1 could be too much. And second of all, I want to get rid of my droplets before meshing, so I don't want to mesh my droplets. So for that, I can do a blast swap here, connect the input of my blast to my attribute warp here, which is the visualization of my flip sim, and I can say add droplet greater than 0.1. So it's going to delete every droplet which has a value of 0.1. So pretty much all the droplets are going to get deleted. And if I say points, and let's say if I do delete non-selected, so we actually see what these droplets look like that we're going to be deleting. These are our droplets. Right, so we don't really want to mesh them because these are lone particles that we don't want to mesh. So delete selected, and we have gotten rid of our droplets here, and now we can proceed to connect the output of my blast to the first input of my particle fluid surface node, and the particle separation set to 0.4. So let's see how that looks. Now this is going to be very low res. It's still going to take its time to compute because there is a lot of points. Well, okay, it didn't take that long. But straight off the bat, you can see that Houdini isn't really handling this very well. And mainly this has to do with the particle separation set so high up. So let's try to drop this down. Let's see how it looks at 0.3. Okay, that's a bit better. So you can see there are no holes in the floor of our mesh, and even though it still looks low res, it's good enough for testing some stuff out. Right, so let's talk about the couple of settings here, i.e. the influence scale and the droplet scale. Now influence scale by default is set to 3, and lower this number, the smoother your mesh will get, but it will add to your computing time. So be careful. Influence scale and even droplet scale, they are RAM intensive settings. So changing these values would definitely be a burden on your resources. Right, so let's drop down influence scale to 1.6. Now you saw the change happen. Obviously the change would be a lot more visible when we will have a higher resolution mesh. Right. Now, the droplet scale is the desired distance between the particles and the generated mesh. The lower this number, the more detail our mesh would be, because it would take more particles into consideration when meshing. So again, this might be high, this might be a burden on your RAM, so be careful changing these two settings. So I'm going to put the droplet scale to 0.8, and we're going to take a look on, so you can see that we have a lot more tiny bits of tiny floaty bits that we can see in our mesh. Right, so let's take a look at the adaptivity now. So adaptivity by default is set to 0.005, and the higher this value, the less polygons you would get in your mesh. Houdini would still add polygons to the areas where it's needed, i.e. our splash, but these empty areas would not have densely populated polygonal data. So if I go here and say, show me the wireframe, there you go, you can see that the density of our polygons is varied. And if I change this number to, let's say, crazy high to 1, you will still see that there is, the higher this number gets, the less the polygons get in the areas that Houdini thinks that it doesn't really need to add polygons there. So for this, I'm going to put that to 0. And the reason behind me putting the adaptivity to 0 is because we want to add some ocean displacement on this mesh in the next chapter. And for us to get really nice looking detailed ocean displacements, we need to have a lot of polygons. And that's the reason that I put the adaptivity down to 0. Otherwise, it's a good idea to have some sort of adaptivity, because obviously it's going to be easier to save stuff out on your disk when it comes to the size of the BGOs. Okay, now let's talk about smoothing, and that is the filtering tab here. I'm not going to play with dilate or smooth, but I do want to play with erode. And what I'm going to do is I'm going to check that on, but I can't because, well, you can see that it's channel reference, it's linked. So let's put that to manual. So dilate, and you can see it's linked. So what I can do, I can say delete channels, and then here delete channels as well, because I want the erode to be independent of the dilate. Right, and I'm going to put the erode to 0.2, and the reason I do that because I want the mesh to erode just a tiny whiny amount, because white water would sit on top of my mesh, and eroding your mesh this way would make the mesh a little smaller than the actual position of our white water. So it's really helpful when you're comping your mesh with your white water for your white water to shine out. Right, and obviously we need the final smooth as well, so we're going to do Gaussian here, which is a crazy level of smoothing, and we're going to put that to 1. But I don't want the smoothing to happen throughout the mesh. So if I go smooth shaded again and I say auto update, you will see that this final smoothing have literally taken out our mesh completely. So what I want to do is I want to add smoothing to the areas. So let's check that off. So I only want to add smoothing to the areas which is not our splash. So around the splash, this plane geometry, this plane area here. And even the erode has like taken the geometry away. So if let's say if I check that off, you will see we would get that back. But obviously we're going to be using erode and then a good particle separation so that doesn't happen. Right, so how can we mask our smoothing? That's the question. And to do that, what we're going to do, we're going to visualize our mask, and we're going to select the velocity range, and we're going to mask this. So what that's going to do is it's going to, so let's check off the erode for now as well, and let's check off let's do the mean value so we are able to see a lot more of our geometry here. There you go. Okay, so what I want is I want anything in the velocity range of 0.2 to 1 to not get smoothed out. And we can also play with the vorticity range, but you need to have the vorticity attribute in order for you to play with that, and that we do. So if you remember, if you go back to your flip sim, in the flip solver under the volume motion and the particle motion, and under the vorticity tab, there is an add vorticity attribute here that we checked on, and in return Houdini saved out the vorticity attribute. So I'm going to check that on as well, and I'm going to put the same value, which is 0.2 to 1, and then let's auto update to see how that looks. Right, so now anything that is purple is not getting smoothed out at all. So let's say if I remove this mask, you would see that my fluid, which is the splashy areas here, are also getting smoothed out. But as soon as I turn on the mask, it's only smoothing out the areas around it. So let's take a look at this in its full res glory. So in the surfacing tab, what I'm going to do is copy my particle separation here, copy parameter, and paste relative references. And what I'm going to do is I'm going to multiply that value by 1.25, as a value of 0.098 is a bit too much for this shot. And then I'll let this compute to see how our mesh looks. Right, so that roughly took a minute and a half to compute. and this is the result that we get. And to be honest, that's pretty detailed. So if I go to my filtering and visualize mask that off, you would see that our colors would go away and we would be left with this. And you can see that the smoothing is being applied to these areas as well on the at the back bit here, but we still have a lot of details to show here, which is great. So if I do smooth wire shaded, you would see there is a lot of detail and highly dense polygons in our mesh. Right, so now let's take a look at the flipbook of this high-res mesh. And you can see that we have highly detailed looking mesh of our flip sim here. It's as simple as that. There is no rocket science to it whatsoever. Obviously, you can use custom VDB nodes. You can dive inside the particle fluid surface node to see the inner workings of it, which is essentially a bunch of VDB nodes connected together to give the results that you want. So you can construct that network manually as well to have a little bit more control, but for the most part, particle fluid surface node really works, and it can yield in high res meshes like this. So now let's take a look on how we can add ocean displacements to our mesh here.